For thousands of years, humans have looked at the night sky and asked a single persistent question: are we alone in the universe? What once belonged to philosophy, mythology, and imagination is now becoming a serious scientific investigation, because modern astronomy has revealed a universe far more vast, complex, statistically rich than early observers could ever have imagined. And the more we learn, the more the question stops sounding fictional and starts sounding scientific. One of the most famous unexplained events is the WOW signal, a strong narrowband radio signal detected in 1977 by a radio telescope studying deep space. It lasted only a short time, stood out sharply from background noise, and was never observed again in the same exact form. Despite decades of analysis, its origin remains unknown, and it continues to be one of the strongest possible anomaly cases in radio astronomy history. Beyond isolated signals, astronomers have now confirmed the existence of thousands of exoplanets across the galaxy. Many of these worlds exist within what scientists call the habitable zone, where temperatures may allow liquid water to exist under the right conditions. While none of these planets have shown confirmed signs of life, their presence shows that Earth-like environments are not unique. It may actually be a common feature of planetary systems. As telescope technology improves, scientists are also discovering that many of these exoplanets have atmospheres containing chemical signatures that are still being studied. Some show traces of carbon-based compounds, while others have unusual atmospheric compositions that do not fully match models of familiar planetary evolution. These findings do not indicate life directly, but they do expand what scientists consider possible environments for life to exist. In more recent observations, unidentified aerial phenomena (UAP) recorded by military pilots and advanced radar (STs) have drawn attention from both researchers and government agencies. These objects have been reported performing sudden accelerations, abrupt directional changes, and flight patterns that appear inconsistent with known aerodynamic principles. Although no verified extraterrestrial origin has been confirmed, a portion of these observations remains scientifically unresolved. Some of the most intriguing aspects of these aerial observations is not just their movement, but their consistency across different regions and time periods. Reports from pilots, radar operators, and infrared sensors sometimes describe similar characteristics, even when recorded under different conditions. While many cases are eventually explained as atmospheric effects or sensor anomalies, the remaining unexplained fraction continues to be studied carefully. In space chemistry, scientists have discovered organic molecules in meteorites, comets, and interstellar clouds. These molecules include carbon-based compounds that are considered essential building blocks for life as we know it. Their presence suggests that the basic ingredients for life are not rare or localized, but instead widely distributed across different regions of the galaxy. This discovery leads to an important scientific implication. If the ingredients for life exist broadly across space, then the formation of life may not be an extremely rare event. Instead, it could be a natural outcome in environments that meet certain physical and chemical conditions. However, whether those ingredients consistently evolve into living organisms remains one of the biggest unanswered questions in biology and astronomy. Another major discovery in modern astrophysics is fast radio bursts, extremely powerful energy pulses originating from distant galaxies. These bursts release enormous amounts of energy in milliseconds, sometimes exceeding the energy output of entire stars over long periods. While some fast radio bursts have been linked to known astrophysical sources like magnetars, others remain unexplained, keeping their full origin uncertain. What makes fast radio bursts especially interesting is not only their intensity, but their unpredictability. They appear suddenly, often from distant and difficult-to-observe regions of space, and in some cases, repeat in patterns that scientists are still trying to classify. This combination of power and mystery makes them one of the most actively studied phenomena in modern astronomy. When we step back and observe the structure of the universe as a whole, the scale becomes almost impossible to fully comprehend. There are billions of galaxies, each containing billions of stars, and around those stars, likely trillions of planets. From a statistical perspective, many researchers argue that it becomes increasingly unlikely for Earth to be the only location where life has ever emerged. Even if intelligent life is extremely rare, the sheer number of planetary environments increases the probability that life could exist elsewhere in some form. This does not confirm anything, but it shifts the question from pure speculation into a measurable scientific possibility. In this sense, the universe itself becomes part of the argument. Closer to home, our own solar system contains ocean worlds such as Europa and Enceladus, icy moons that are believed to contain vast liquid oceans beneath thick layers of ice. These hidden oceans may contain energy sources and chemical conditions that could support microbial life, even in the absence of sunlight. This makes them some of the most important targets in the search for extraterrestrial biology. Future space missions are already being planned to explore these moons more closely. Using advanced probes and ice-penetrating instruments, if microbial life were ever discovered in such environments, it would immediately confirm that life is not unique to Earth. Even a single independent origin of life elsewhere would completely reshape biology, chemistry, and our understanding of existence itself. Beyond moons and planets, scientists are also studying interstellar space itself, where vast clouds of gas and dust drift between star systems. These regions are not empty. They contain complex chemistry, energy interactions, and molecular formations that continue to surprise researchers. Some theories suggest that prebiotic chemistry could begin even before planets fully form. At the same time, advancements in space observation have allowed scientists to detect thousands of new star systems with increasing precision. Each discovery adds another potential location where life could emerge under the right conditions. The more data we collect, the more the universe appears structured in a way that supports chemical and planetary diversity. Another important factor in this discussion is time. The universe is over 13 billion years old, while Earth-based intelligent civilization has existed for a tiny fraction of that time. If other civilizations arose earlier in cosmic history, they could potentially be millions or even billions of years ahead in technological development, which expands the scope of possibilities even further. This leads to one of the most thought-provoking ideas in modern science: the possibility that intelligent civilizations, if they exist, may already have the ability to detect Earth, not necessarily to interact, but simply to observe through signals, light patterns, or atmospheric signatures. From a distance, Earth itself could already be visible as a planet with detectable chemical activity. If that possibility is considered seriously, then the question changes in nature. It is no longer only are we alone, but also are we already part of a larger cosmic network we do not yet perceive. This shifts the search for life from passive observation to active cosmic awareness. So the question remains open, supported by increasing amounts of data, but no final answers. Are humans alone in the universe, or simply early in discovering that we are not? Because somewhere in the vast darkness of space, something may already be listening, and we are only just beginning to learn how to listen back.